Bismillahirrahmanirrahim. Assalamu alaikum everyone. Welcome to the part 3 of the sensor series. Today we will discuss about optical proximity sensor. In this video I will not do a in-depth analysis of the inner working and the construction. I'll just highlight the basic working principle and move through the fluid sim software. So optical sensor has basically two main components. One is the emitter and another one is the detector. Emitter sends a light beam. That light beam hits the object and then reflects back to the detector, and then the sensor decides that there is an object in front of it. This optical proximity sensor works in three modes. First one is the opposed mode. So here basically what happens is that we have an emitter and we have a detector. They are in separate places. The emitter sends a light beam and this light beam hits the detector. But if an object moves in front of this emitter and this detector, then the emitted light from the emitter won't reach the detector. That's how the sensor decides that there is an object in front. This is the working principle of the opposed mode, and this is very accurate and works over a long distance. The second one is the retroreflective mode. In this mode, the emitter and the detector housed in the same place, and we have a reflector in the opposite side. So light beam emits from the emitter, hits the reflector, then move back to the detector. If a object comes in between, then what happens? Then this emitted light won't reach to the detector and the sensor will sense that there is an object in front. But what happens if the object is very shiny? Then the emitted light will be reflected to the detector, and in a normal sense the sensor will detect that there is no object in front, but that's a false prediction. So to overcome this situation, this reflector has a polarized coating which makes the emitted light into 90-degree polarized angle. So if there is no object in front, then the emitted light will hit the reflector, it will get 90-degree polarized, then it will move back to the detector. If the detector senses that the light emitted is 90-degree polarized, then it decides that there is no object in front. But due to this object, this emitted light won't get polarized at 90-degree angle. When this ray reflected back to the detector and the detector sees that the light is same as the emitted light, then the sensor decides that there is an object in front. So this is the working principle of retroreflective mode. Now we have the diffuse mode. Here also the emitter and the detector housed in the same place, and we have an object in front. This mode is very simple. The emitted light just hits the object and then reflects back to the detector. But this is less precise, especially with the varying colors or texture of an object. Now here are some advanced technique which includes focused optics, multiple points, fiber optics. We can adapt these techniques based on various applications. Here are some key considerations using this sensor. Alignment of the emitter and the detector is very crucial. Beam width versus object size affects the detection accuracy. So, for example, we have an emitter here and we have a detector here. So, emitter is emitting light, right? So, suppose an object which is very small comes between these two, then the emitted light will just pass by this small object. The object won't be detected. So, object size matters. And ambient light is filtered using modulated light signal for better precision. Here is the industrial level optical proximity sensor. Here we have an emitter. The emitted ray will be detected by this lens. We have a detector inside and some complex circuit board which will make the decision of the presence of an object. Based on that, we get an output signal from here. Now let's see in the fluid sim software. I am using the previous circuit. Here I have the capacitive sensor. I'm going to remove this. I have an optical sensor here. I'll use this. So let's simulate. It's very simple. Suppose there is an object. So based on that, see, so the emitted light hits the object and moves back to the detector, and this sensor will then give a output signal, which will turn on this LED and the buzzer. So it's very simple, and that's all. I hope you understood. If you have any confusion, please write in the comment. See you in the next video. Allah Hafiz.